Have you ever noticed something strange about our planet? Only one. Third is land, and almost two-thirds is water. So here's the big question. Why do continents stand tall, while oceans sit low and deep? Is it just random? Or is there a hidden rule? Welcome to GeoRoots. Today we're uncovering the secret behind the origin of continents and oceans. Let's rewind Earth's story to the very beginning. Early Earth was extremely hot, a glowing molten ball. Slowly, the outer layer cooled down and formed a solid crust, while the inside stayed hot and active. Water vapor in the early atmosphere condensed into rain, and that water collected in the lower, depressed parts of the crust. Those lows became our oceans, and the higher, bigger parts of the crust stood out as the first continents. So from the start, Earth had a basic pattern: thick, high-standing continental crust and thin, low oceanic crust. Now, look at a world map carefully. About 71% of Earth's surface is ocean. Only about 29% is land. Most of that land lies in the northern hemisphere. Many continents and oceans have a kind of triangular shape, broad in the north, narrower towards the south. These patterns made geographers and geologists ask, are continents and oceans fixed and permanent, or have they moved and evolved over time? Before we had modern plate tectonics, scientists tried to explain these patterns in creative ways. One early idea was the tetrahedral hypothesis by Lothian Green. He imagined that as Earth cooled and shrank, its shape changed slightly from a smooth sphere into something like a tetrahedron, a shape with 4 faces and 4 corners. In that picture, the faces became ocean basins, the corners became continents. It was a clever guess for that time, but it doesn't match modern geophysical evidence, so today we treat it more as a historical stepping stone than a correct model. The real breakthrough came with Alfred Wegener in the early 1900s. He looked at the jigsaw-like fit of South America and Africa and found similar rocks, fossils, and ancient climate signs on continents that are now far apart. He proposed the continental drift theory. All continents were once joined in a single supercontinent called Pangaea, surrounded by a huge ocean called Panthalassa. Over millions of years, Pangaea broke apart, and the pieces drifted to form the continents and oceans we see today. Wegener didn't know how the continents moved, but he was right that they do move. Today, we have a more powerful answer: plate tectonics. Earth's outer shell is broken into plates, big, rigid slabs of lithosphere that float on a softer, deeper layer. At mid-ocean ridges, new oceanic crust is created. It's thinner and denser, so it sits